So we were discussing about additive process. So additive process is in rapid prototyping. Additive rapid prototyping operations all build parts in layers which are typically zero point 0.1 to zero point 0.5 millimeter thick and can be thicker for some systems. So in additive processes, we basically like operations are we build the part in form of layers, and we on one layer is embedded over the another layer, and it is typically about zero point 0.1 to zero point 0.5 millimeters, and it can be thicker for some systems. It can be moreover, it can be thicker more also. Then additive operations require elaborate software. So when we have to we can say imply the additive process, it has to be somewhere elaborative software we have to use. The first step is to obtain a CAD file description of a part. So the inputs for this is we require basically we will be requiring a CAD file out of this. So firstly we have to start with the CAD file. Then the computer then constructs slices of three-dimensional parts. So now with the help of computer, we construct that we can say design or that part in the form of slices basically. Yes. So one over the another, it is put into the form of slices or layers. Each slice is analyzed separately and set of instructions is compiled in order to provide the rapid prototyping machine with detailed information regarding the manufacture of a part. So like we what we do, we analyze each of the slice separately, and then we have to, we can say we have a fixed set of instructions that is compiled in order to provide, like we give the instructions to the RP machine, rapid prototyping machine, in the form of, we can say, instructions, like there is a fixed set of instructions that is compiled, like which layer has to be embedded over the second layer, then third layer, then fourth layer. It is basically we can say a sort of a program that is input into this. The instructions are provided in the form of layer basis. Then and detailed information regarding the manufacturer, like if how many number of layers will be there, and what will be the curve after what will be taken of the maximum number of layers, and how will be the shape of that each layer, how will the thickness of each layer that is to be started. So we have, that is all is being provided in the set of instructions, or we can say it is fed in the form of your program for that, and that program is basically fed into the system, and that works, the RP system works on this particular set of instructions to get the analyzed part out of it. Starting material in material addition in RP. So liquid monomers that are cured layer by layer into solid polymers. So we have the, we can say the starting materials for this, we have liquid monomers, and that are cured one over another layer by the help of solid polymers. Powders that are aggregated and bonded layer by layer. Then we have the powders that are aggregated on this and then bonded, that is layer upon this. So solid sheets that are laminated to create a solid part. Then we have powders also. Then we have the solid sheets that are laminated to create a solid part, like sheets, solid sheets of a certified thickness. We get the standardized thickness out of it, and that sheet, laminated sheet, has to be embedded one over the another for that part. So, so what are the rapid prototyping processes with this? For we have three phases: liquid, powder, and solid. For this, the liquid we use stereolithography. Here, the layer creation technique is done with the help of liquid layer curing, and then phase change type is photopolymerization. And the materials for this are photopolymers, acrylates, epoxy, colorable resins, fillers, resins. Then solid phase curing is the second technique, the process basically, and the layer, how the layer is being created in this part is liquid layer curing and milling. Then photopolymerization, the phase change type, that is the help of same in the case of, as in the case of stereolithography, that is photopolymerization. Then the material for this is photopolymers. Then third technique is fused deposition modeling, FDM we call it. The layer and layers are created by extrusion of the melting plastic, and the phase changes is done by solidification by cooling. Then material are thermoplastic, ABS, polycarbonate, elastometer, and wax polymers, wax. Then ballistic particles, That is manufacturing, that is droplet deposition is a technique. Then solidfication by cooling in this part. Then it is being done with the help of your solidification done with the help of cooling. And the polymers and wax are used as the input materials for this part. Clear? So then we come in for your powder in the form of, they have the three-dimensional printing we have, and the case of three-dimensional printing, then we get to we can say we take out of it, and that is binder droplet deposition into powder layer, that is layer fusion technique. And no phase change in this case is case, and the material input materials are ceramic, polymer, and metal powder with binder. Then selective laser sintering, that is SLS. The layer of powder is created by layer creation technique is the layer of powder each over one over another. There is a layer of powder of this. Then laser driven sintering and melting. The phase change type is done by laser driven sintering and melting. The polymers, metals with binders, metal ceramics, and science with binders are the materials for this. And then in case of solid, we have like we were discussing about laminated sheet. So laminated object manufacturing is the process. Deposition of sheet material layer over layer after layer is created by deposition of sheet material, like one layer of sheet, then second layer of sheet, then third layer of sheet. Then in this case, it remains in the same phase, in the solid phase only. And the materials for this is papers and polymers. The common approach to prepare control instructions part program in the current material edition RP requires and technique that require the following steps are being considered in this. The first one is geometric modeling. This consists of modeling a component into CAD system to define the enclosed volume. Like we first ever the we can say the step that has to be performed is the geometric modeling. Then what we do, we take it for a geometric modeling, and then we produce a CAD model out of it of the part. Then the solid modeling is the preferred technique because it provides a complete mathematical representation of the geometry. Then we use the solid modeling because we have to get out the proper mathematical representation of the particular geometry. What is the area? What is the volume of this? What are the dimensions for this? So solid modeling is done after the CAD system. We can say, and then second is a tessellation of the geometric model. In this system, CAD model is converted into a format that approximates its surface by triangles or polygons. So then this is a tessellation. Tessellation is basically we convert the CAD file into the format that is in the form of like triangles, polygons, yeah, and with their vertices arranged to distinguish the object's interior from exterior. Like we make it in the form of triangles or polygons, and the vertices are we can say arranged in such a way that interior and exterior of the part, like internal parts and external parts, on the way are distinguished, or we can say they are separated. Yes, with the help of vertices of this triangles and polygons for this. The common tessellation format used for rapid prototyping is STL, which has become de facto standard input format for nearly all RP systems. So STL format is basically the common, we get a standardized format, clear. So that is normally now becoming the standard. We normally the all the RP system, all not all, but maximum of the RP system are using this STL format. Then third is slicing the model into layers. In this step, the model of the STL file format is sliced into closely spaced parallel horizontal layers. Conversion of a solid model into layers is illustrated. These layers are subsequently used by the RP system to construct the physical model. So what we do in the third part is the slicing of that model into layers. Though now the model of an STL file is basically sliced in a closely shaped parallel horizontal layer. Like if we see in this figure, this is A part is the actual shape of the part. Then this is a STL file. Now we see in this part, it is sliced into a closely spaced parallel horizontal layer, like it is parallel and horizontal layer it is this. The conversion of solid model into layers is illustrated in this part. So solid model is become, we can say is converted into the, we can say, solid layers and is illustrated. These layers are subsequently used by RP system to construct the physical model. So There is a layer in these layers is basically of the rapid prototyping system that is used for the construction of the physical model. By convention, the layers are formed in XY plane orientation, and the layering procedure occurs in the Z direction. So normally we see in this part the convention, the layers are formed in XY plane orientation. Clear? The layers is taken in the XY plane, and the layering procedure occurs in normally in the Z direction. The layering is done in the Z direction, and the orientation of this is taken in the plane XY plane orientation, and normally the layering is we can say done in with respect to the Z axis direction for this. Now next comes the production of STL file from 3D CAD model. Now how it is basically the STL file is created from the 3D input model. There are many different ways to 3D print an object, but nearly all of them utilize computer aided design, that is CAD files. CAD files are digitalized representation of an object. So normally these CAD files are basically the digitalized representation. Like we have this dimensions, we have this angles, we have this references, we have the coordinate systems out of this. They are used by engineers and manufacturers to turn the ideas into computerized models that can be digitally tested, improved, and most recently 3D printed. So in this case, these are used by the we can use by the engineers and manufacturers. Like we are converting the drawing into computerized models, and then that model can be tested for its improvement. And it is mostly the normally we are mostly using is that is 3D printing out of this. In 3D printing and additive manufacturing, CAD files must be translated into a language of a file type that 3D printing machine can understand. So the main issue out of this is coming that the CAD files is having, we can say, a different language out of this. So that and we are using it on the printing machines, basically 3D printing machine. So that language is to be understood by the 3D printing machine. Yes. If we say like if the CAD file is in a different language and that commands are not being taken off by the 3D printing machine, that will not be printed. So it has to be converted or it has to be translated into a language, or a file type is to be changed like in such a form that is to be, we can say, understandable, or that it is to be gettable by a 3D printing machine. Then here comes into play the STL, that is Standard Text Specification Language. It is one of the files, such file types and is language most commonly used for stereolithography and all other additive manufacturing systems. So in this case, what we see for this is like this is of a, such a file type and is a language. Normally, STL file that we were discussing earlier also. STL file is a normally most adaptable format that is being used, and normally for stereolithography and other additive manufacturing processes, because it is quite easy and it is standardly available and we can say readable by most of the editing additive manufacturing processes machines. The sense additive manufacturing works by adding one layer of the material on top of another. CAD model must be broken up into layers before printing it in 3D system. So like additive manufacturing is like we are adding the layer after layer. Layer that on top of this, like it is a lower layer, then on the top there is we are putting on a single layer. Then again we are putting on another layer. Then we are putting like we are till the requisite height of that model is achieved in this part. Clear? So CAD model must be broken into layers and before it is to be printed. So that model has to be we can say broken up in the form of layers and so that it to be printed in 3 dimensions for this. STL file put CAD model giving up 3D printing machine information it needs to print each layer of an object. So what is the we can say the main objective of the STL files? That is, they cut up the CAD models, clear, and they we can say they retract the information out of the CAD model, and they're giving up the 3D printing machines and it providing it to 3D printing machines the information that is requiring to print each layer of an object. Like for every layer, it has to be the command from the CAD model is to be in, we can say read or translated into the readable language for this layer. So this is to be taken for that process. So